How was your 3-day weekend? I hope you're ready to learn, third grade. Okay. Last time we learned how to use multiplication to find equivalent fractions. So when we had the fraction 2/3, we just wanted to multiply the numerator and denominator by the same number to find an equivalent fraction. Here's another example. We also learned that we can use division to find equivalent fractions. So if we had the fraction 6/12, we want to divide by a number that's the same with the numerator and the denominator. Okay, so 6 divided by 3 is 2, 12 divided by 3 is 4. Here's another example. 2/4, if we divide the numerator by 2 and the denominator by 2, we get 1/2. 1/2 is actually in the simplest form of the fraction 6/12. We cannot find another common divisor for the numerator and the denominator. So now it's in simplest form. Well, today let's talk about using models to compare fractions. Here's an example. Zoe served 1/2 of a vegetarian pie. Lisa served 3/4 of an equal-sized vegetarian pie. Abby served 1/4 of another equal-sized vegetarian pie. So I want to compare the pies that Zoe, Lisa, and Abby served to see who served the most pie, who served the least amount of pie. So to draw it, I'm going to use a model. Now, it says that the vegetarian pies that they served were of equal size amongst the 3 girls. Now, we can only compare fractions from the same whole or equal size whole. Let me tell you what this means. Look at this model here. This model shows 1/2. This model shows 3/4 because 3 parts are shaded and there's 4 parts total. And this model here shows 1/4 where 1 part is shaded and there's 4 parts total. But the thing is, are these all equal size? They're not. First of all, this is a bar model and then this is a circular model, right? And although these two are circular models, one looks way bigger than the other. So they are not showing equal size holes. You see how this is one hole, this is one hole, and this little thing here is also one hole. They are not equal size holes. So when we want to compare fractions, we have to make sure the whole is the same. So these are not good examples of equal size wholes. Let's look at some good examples of equal size wholes. Here's one. Here's 1/2 of a pie. You can see that the whole is this circle here, and then half of it is right there, right? So that represents 1/2. Here is 3/4 of a pie. I drew these black lines here to show you how there's 1, 2, 3, 4 parts total, but 3 parts are the pie. So the fraction here represents 3/4. I also wanted to show you up here how there's also 4 parts here, but 2 parts out of the 4 are shaded, which makes 1/2. And here, this shows 1/4 of a whole. Now these are great models with equal size wholes. Now we can compare the fraction. From here, we can see easily who served the most pie. We can also see easily who served the least amount of pie. I see that 3/4 here is greater than 1/2, and 1/4 here is less than 1/2. Just as a reminder, this sign here means greater than. When we read words or when we also read math problems, we'll read it from left to right. And then, so when we read it from left to right, we're going to read this fraction first, 3/4, and we're going to see this. You see how there's an open mouth here, okay? This side is wider than this little point here, isn't it? So you can think of this as greater than, and then what is it greater than? 1/2. Okay? If I read this second line here, where it says 1/4, and then here, I see a little point here, but then I see a wider space here. So then this is less, right, than this. So it's less than 1/2. Another way that students like to remember this is they like to think of this as kind of like crocodile teeth, I think. That's what they tell me. And how usually the crocodile wants to eat the bigger number. Okay, so then that would always be greater than, and then when the crocodile teeth is pointing to this, then that's less than here. Okay, this is less than. Okay, and again, we always read it from left to right. Sorry, my videos keep going, my slides keep going back and forth. Okay, so Lisa had a bigger part than Zoe, and 3/4 is greater than 1/2. Okay, so 3/4 is greater than 1/2. That means Lisa served a greater part than Zoe. And then also, Abby served a smaller part than Zoe because 1/4 is less than 1/2. So those are our conclusions that we reached as we compare the fractions. Here's another example. These are number lines. We have one number line here, another number line here. Well, first off, we have to ask, do they represent the same whole? Let's see, from 0 to 1 is here, okay. From 0 to 1 is here. Yes, they are the same whole, okay. Now, on a number line, we know that 1/2 and 2/4 are equivalent because the number lines represent the same whole and the fractions are vertical. They're stacked on top of one another. So we see that these are equivalent. Now, we want to compare 1/4 to 1/2, and then we also want to compare 3/4 to 1/2. Which one's bigger? Which one's smaller? Well, I see from the number line 3/4 is greater than 1/2 because it goes past 1/2. I see that 1/4 is less than 1/2 because 1/2 goes past 1/4. 1/4 does not go past 1/2, so it is less than 1/2. Okay, please pause the video and try numbers 1 through 5 on your own. When you're ready, let's see what you get. Alright, you must be ready. Let's look at number 1. So they already shaded the parts of the model for you. We just want to see which one's greater than the other. If you see here, there's more shaded areas than this circle here, right? So 5/6 is greater than 1/2. Let's look here. Well, I see that they're the same whole, and it looks like the green parts are more than the red parts. So 1/2 is less than 7/8, okay? Now we're gonna mark these number lines here, okay? So they label the starting and the end points. The starting and the end points are the same. But let's see, for this number line here, there's 1, 2, 3 total parts. For this number line here, there's 1, 2, 3, 4 total parts. So I know my fraction here, my denominator will be the total number of parts. So for this fraction, because there's 3 total parts, my denominator will be 3. And for this fraction here, for these fractions here, there are 4 total parts, so my denominator will be 4. So I'm going to just draw my denominators for now. Now from 0 to here, it's 1 space away, so my numerator is 1. From 0 to here, it's 1, 2 spaces away, so my numerator is 2. From here, 0 to here, it's 1 space away, so my numerator is 1. From 0 to here, it's 1, 2 spaces away. So my numerator is 2. From 0 to here, it is 3 spaces away. So my numerator is 3. So it looks like this. Now we want to use our number lines from 3 to compare these fractions here. But the thing is, you guys, they're not stacked one on top of one another. So what can we do? So when two or more number lines are not on top of one another and they have the same whole, what can we do? This is my tip for you. I would get your pencil, well, in my hand I have a pen, and I would mark the starting point at the tip of my pencil and the fraction where I'm trying to measure it to see where it ends on my pencil, okay? So that's what I would use. So let's see, for number 4, I have 2/3 and 3/4. So 2/3 is my first number line. So I'm going to take my pen, and you can't see where I'm pointing it at, but you'll have to trust me. I'm on my computer screen. So 2/3. So 2/3 is about right here, from my tip here all the way to my finger here. And then now I want to compare 3/4. So then 3/4 is on my second number line. I'm going to see, does it come here before my index finger, or will it come after my index finger? Okay. Oh, okay. I see that 3/4 comes a tiny bit after my index finger. So which one's bigger? 3/4 is bigger, right? So that means 2/3 is less than 3/4. Okay. So that's one way that you can do it. All right, using your pencil. If the number lines are next to one another and you have to compare them, all right? But if you can't, instead of doing it that way, I will show you the number lines on top of one another, okay? So I just screenshotted that and I placed it on top right here. So the zeros line up and the ones line up, okay? So they show the same parts of a whole. So 2/3 and 3/4. So here's 2/3. And here's 3/4. You can see 2/3 comes before 3/4, so it is less than 3/4. Now let's compare 1/3 and 1/4. 1/3 is here, 1/4 is here. So 1/4 comes before 1/3. 1/3 comes after 1/4, so 1/3 is greater than 1/4. All right, I think you're getting it. Ooh, I look so blurry for some reason. Let's see. Is that better? Okay. I still look a little blurry, but that's okay. All right. We're going to use models to compare like fractions. Now you might notice here, I didn't just say fractions. I said this word like fractions. I'm going to tell you what that means. Like fractions are fractions with the same denominator. That means they have the same number as the bottom number. Let's look at this example. Gina, Heather, and Rita each have an equal-sized paper plate for a craft project. Each girl divides her plate into 8 equal parts. Gina decorates 3/8 of her plate. Heather decorates 5/8 of her plate. Rita decorates 8/8 of her plate. So here is a model of Gina's plate, Heather's plate, and Rita's plate. Like fractions have the same denominator. So because they have the denominator of 8 in this case, which is the same, we can only compare the numerators if we want to make it easy for us. So the numerator of 3/8 is 3, the numerator of 5/8 is 5, the numerator of 8/8 is 8. By looking at the numerator, we can see that the biggest numerator will be the largest fraction. Okay? The smallest numerator will be the smallest fraction. So we know that 5 is greater than 3. So 5/8 is greater than 3/8. Who has 5/8? Heather. Who has 3/8? Gina. So Heather decorates her plate more than Gina. We also see that 8 is greater than 5. So Rita decorates her plate more than Heather. So Rita decorates the most and Gina decorates the least. And we can just look at the numerator because they have the same denominators, or you can just look at the models that are drawn or that you know how to draw. All right. Pause the video, try number 7 on your own. There are A, B, C, D parts in number 7. So look at the models carefully and try your best. See you soon. Hi again. Okay, let's take a look. It says Rachel bakes 2 equal-sized chicken pies. She cuts each pie into 6 equal parts. Clara eats 3/6 of a pie and Priscilla eats 2/6 of a pie. Okay. So I guess Rachel doesn't even eat her own pie. She's just baking for other friends. That's nice. Okay. So Rachel has 2 chicken pies that are the same size. She gives one to Clara, one to Priscilla. Okay, so Clara eats 3/6 of the pie. Priscilla eats 2/6 of the pie. So which is greater, 3/6 or 2/6? Well, these are like fractions because 6 is the denominator. So let's look at the numerator. Okay, 3 is greater than 2. So 3/6 is greater than 2/6. And who ate 3/6 of the pie? It was Clara. So Clara eats more. So let's look at Priscilla. It says Priscilla gives her remaining pie to Tom. So Priscilla only ate 2/6 here. She only ate this part here. What fraction did Tom eat? Well, again, there are 6 total parts, so 6 goes in the denominator, and Tom ate 1, 2, 3, 4 parts. So the fraction is 4/6. Tom eats 4/6 of the pie. Which fraction is greater than the others? Well, I noticed 3/6, 2/6, 4/6 all have the same denominator. So let's look at the numerator. The numerator 3, 2, and 4. Sorry, my slide went back, but now it's in the correct spot. So 3, 2, and 4, it looks like 4 is greater than 3, which is greater than 2. Okay, so 4/6 is greater than 2/6 and 3/6. Tom eats the most because he eats 4/6 of the pie. Who eats the least? Which one is the least denominator, 3 or 2? It's 2. So that's Priscilla. Priscilla eats the least. All right. Again, feel free to slow down the video if I'm talking really fast. You don't need to keep up with the same pace that I'm talking. If you need to really slow it down, just slow it down, pause the video, think about it more carefully, work it out on your own, try to make sense of it, and it's okay, all right? That's the beauty of video. You can pause it, fast forward it, slow it down. It's up to you, okay? All right. Now let's use models to order like fractions. So remember, like means what? Do you remember? Fractions that have the same denominator. Okay, so let's look at this example. I have my fractions 2/6, 3/6, and 1/6. They are like fractions because they have the same denominator of 6. What would the models look like? Well, 2/6 looks like this, where there's 2 parts shaded out of the 6 parts total. 3/6 looks like this, where there's 3 parts shaded out of the 6 parts total. 1/6 looks like this, where there's 1 part shaded and 6 parts total. Notice they have the same size whole. Okay, because they have the same size whole, we can easily compare the fractions by looking at the models. I see that this is shaded more than this, which is shaded more than this, right? So we're going to order from least to greatest. So 3/6 is greater than 2/6, which is greater than 1/6. So this is the order from greatest to least. 3/6 is the greatest, 1/6 is the least, 2/6 is between 3/6 and 1/6. Pause the video and try this on your own. Hi again. Alright, let's order these fractions. So they drew the model for you, and which one looks like the greatest? It's the one that's shaded the most, which is this middle bar here. So that's 5/7 is the greatest. Which one's the least? It'll either be the top model or the third model. Is it the top or bottom model? It looks like the bottom model is shaded less than the top model. So 2/7 is the least. Let's order it from least to greatest, it says. So the least fraction is 2/7, then the next one is 3/7, and then the next one is 5/7. Sloth is amazed at your level of understanding. Keep up the good work. All right. Now we're going to compare unlike fractions with the same numerator. Now look here, it's not like fractions. The word here is unlike fractions. So I know that like fractions means they have the same denominator. What could unlike fractions mean? Unlike fractions mean that they have different denominators. Let's look at this example. Which is greater, 3/5 or 3/6? Notice my denominators 5 and 6 are different, but my numerators here are the same. Okay? So this would be my model for 3/5, and this would be my model for 3/6. Notice again, they have the same part of the whole. From the model, we can easily see which one is greater by the total space the shaded areas takes up, right? It looks like there's more orange shaded area than the blue shaded area. So 3/5 is greater than 3/6. But the thing is, what if there was no model? What if we only had a fraction? If we only had a fraction where the denominators are different, which means that they are unlike fractions, you should, and the numerators are the same, you should compare the denominators when the numerators are the same. So here's my denominator of 5 and 3/5. Here's my denominator of 6 and 3/6. The greater fraction is the one with the smaller denominator. So let's see, 5 or 6, which one's smaller? 5 is smaller, so that's the greater fraction, 3/5. 3/5 is greater than 3/6, according to that rule. But is it true? Do you remember what the model looked like? Here's what the model looked like. Here's 3/5, here's 3/6. Yes, it is true. So this rule stands. When we have unlike fractions where the denominators are different, but the numerators are the same, compare the denominators. The greater fraction is the one with the smaller denominator. Let's look here. Please do guided practice 9 and 10. These will be our last two problems for today. Pause the video and I'll be waiting. Hi again. Okay, let's see what you have. So we have these two models, and we want to find which is less, 3/8 or 3/5. Now, they're unlike fractions because their denominators are different. We have a denominator of 8 here, we have a denominator of 5 here, but their numerators are the same, 3 and a 3. So the greater the fraction is the one where the denominator is less. 5 is less than 8, so 3/5 must be the greater fraction. And when I look at my model, I see that's true, because 3/5 here, the shaded parts, is larger area than the purple area here, right, in the first model. So 3/8 is less than 3/5. Now, which one's greater, 1/3 or 1/7? Well, first, this represents 1/3, and this represents 1/7. because here there's one shaded part and there's 3 total parts. For the second bar model, there's one shaded part and there's 7 total parts. Now, which one is greater? Remember, when the fractions are unlike fractions, which means they have different denominators, which they do here, and if they have the same numerator, of which they do here, which is 1, the one with the lesser denominator is the greater fraction. So here, 3 is less than 7, so 1/3 is greater than 1/7. Yeah, keep practicing, and I know that you'll get better. I know there's a lot of rules that you're trying to understand, a lot of vocabulary that you're trying to remember, like equivalent fractions and simplest form and bar models and whole, WHOLE, and numerator and denominator and gosh, what did you learn today? You guys learned like fractions and unlike fractions, and woo, that's a lot. But with practice, you guys will remember it more and more, and you'll get better and better with it. Okay, so keep at it. Okay, don't give up. I know it's a lot to take, but keep at it. Okay, I know you can do it. Alright, that's all for today. So I will see you next time. Bye.